guys, this is Jacob. Today we're gonna do a video on a tool called MindSearch. This is very similar to what Perplexity does. The GPT, but also depends on real-time web search. So when you actually read, usually just talk to the model, but for ARAG approach, you usually just get some prompt model and you basically get the results and then go to the next prompt, send to the model give you a response, and then get the response and compose it, and you go to the prompt and so on and so forth. The RAG approach is very popular, but most of the methods today are really just based on internal pipelines. For the web GPT or for Perplexity or those products, the great thing that they're actually based on the real data. For example, if you search something or just prompt something as an initial prompt, it will basically get some real data from like the search engine, maybe Bing or Google or some other search engine. To get real-time data, generate another prompt. So then, as an intermediate result, and combine with some of the existing prompt in the framework, then they send out to search engine for another round. So back and forth, they will actually get a really good results like what Perplexity does. So let's dive into it. Check out this framework called MindSearch. So how does it work? Let's first check out the GitHub repo. You can just Google it, and MindSearch will basically pop up as the first result. And so what this MindSearch does is as what we just talked about. So to install it, it's actually very straightforward. I just do a git clone and just do a pip install for the requirements, and you can just start the server as they showed in here. And if you want web front-end UI, you can just do a Node.js. They provide Node.js. The easiest way is actually doing a Gradle. So then you can actually just go to the Git repo and then just run this command. So we'll actually spin up the Gradle, which is awesome. I'll demo that in a little bit. So let's go to the terminal. So we cannot actually do this in Kaggle because the default model that MindSearch uses is actually exceeded 16 gigs. So the notebooks, like for example, like Colab or Kaggle, they only have a little bit less than 16 gigs. So those won't work. So we have to use an actual GPU box to demo this. So we use AWS. You can use any GPU box that's available, that's efficient, that's economic. So, but let's just go to the terminal to see how that works out. So here's the terminal. And so basically we start up one for server, one for client. So then you see it, basically we just copy it. First, we just start up the server. You can see the server is actually starting up. It's running on port 80. Let's also start the client. You can see that actually then it will show you a radio link. Paste. Control click either way. Paste in it. So go back to the browser. see we have a Gradio UI that's actually connecting to the server that we just spin up. So let's just test something to see how that works. For example, we want to figure out what are some of the most popular AI YouTubers today. I just want to test it out. Let's say hello. Who are some of the most popular AI YouTubers? Let's just run this very simple query to see how this actually processing that query. So there's a planner, there's a searcher. The planner is basically running this RAG pipeline. The searcher is when you actually run a prompt, it will actually search the internet and then get a response and compile to another prompt. So let's hit submit. So see that's actually running. Let's go back to the terminal to see how it actually works in the back. See, first they'll first download the model. We actually downloaded the model, so it didn't really show the status bar. But I will download the model first, and they'll do a turbo mind version. See that's being running. Just wait till conversion complete. Okay, the conversion complete. So let's go back to the browser to see how this actually works. So you can see this is actually generating a web search graph for the information we just put in, which is who are some of the most popular AI YouTubers. It basically says to find the most popular AI YouTubers, we need to focus on channels that are known for their AI related content. So it's starting to search the internet now. So you see the queries they used, also the browser or the search engine they use, I believe is Bing. So you can start those search. Then they will get the results. And next, they actually want to figure out what the results are and then pick up the relevant results to combine and then to build the next prompt. So then you can see it's actually going in the searcher. So then you can basically just start thinking, start building. You can see it's actually running some of the queries, running some of the requests on the internet, on the actual search engine. So you see they actually got some of the results already. So yeah, so when they finish the analysis and finish the searching, so you can see it's actually sending back to the RAG pipeline. So they actually based on the Q&A pairs, based on the research, they basically got the results. That's how it works. So it has like Matt Wolf, it has West GPT as the most popular AI YouTubers channel. So you see that's actually pretty nice. Because it's real time, so it it will bring back different results, a little bit different results every time. We also ran similar queries again, so you can see a little bit. So it's a slight different, but mostly similar. So if you look at the other query that we ran earlier, it's basically find all the YouTubers and very popular YouTubers and then figure out what are actually relevant to the AI space. What the results they get is a little bit different. Let's say they have Grant Sanderson, they have deep learning AI, Toomey's papers, Sendex. If you run the same thing, in Perplexity, you see there's some common results like Matt Wolf and Toomey's papers, right? So it's very similar, and there's Sendex, but there's a little bit different result as well. It works in a similar fashion, but it's just a slightly different, probably algorithm and slightly different improvement for different frameworks. So it's actually working very nice. You can see that, right? So yeah, I think this video just run a very quick demo on how you can set up a Perplexity-alike GPT system on the local GPU box. If you have a laptop or PC that has GPU, you can set up in a similar way, but we actually set up on the GPU box on AWS. So that being said, hopefully this is helpful, and if you really enjoyed this video, please subscribe or like it. Thank you so much. See you in the next video.